curriculum. And as you can see here, I show this for every unit, but these are the main ideas that are going to be on the exam. And as you can see, most of it is programming and algorithms, 35%. So I remember, at least on my test, most of it was asking about like what would happen in this program, or what is this program, what's the purpose of this program, or what part of this program do you have to take out to make it correct. So most of the exam is that. So if you have any questions, please let me know because it's pretty important. Okay. So the first basic, okay, actually, first of all, can everybody just say in the chat like your experience with programming? Because it's kind of hard to learn in the beginning, but if you guys already have some base knowledge, it'll be like a lot easier. So just let me know in the chat or by unmuting yourself like your experience with programming. But I'm gonna start from like the very beginning, but usually you guys will learn all of this in the span of a school year, but I'm kind of like condensing it all into 1 hour. So obviously I'm gonna leave out some parts, or I'm gonna like speed through it. So please let me know if you have questions. Um, okay. The two people who responded said that they have done some coding in like Python and stuff. Um, on the exam, they're gonna be using pseudocode, which isn't any particular programming language. It's just something they like made up that is just like commands and stuff. It's not like an actual programming language, but the one that we're gonna be using is JavaScript on code.org. But I'll show you guys all the pseudocode blocks later, but you don't have to know any particular language for the exam. Oops. But most of this stuff transfers between languages, so you guys will be fine. Okay, let's actually start now. The first part of programming what you have to know is variables, and you guys, if you have done other programming languages, already know this. Variables are basically like math of a value that is placed into some like the name of your variable. So a value is a piece of information that can be put into variables. So if you can put numbers in it, so any digits 0 through 9 or whatever else. Strings, you could put characters or words, and these are put inside double quotes. So hold on. Okay, so let's say you want to name your variable birthday. If you wanted to put a number, you could just put whatever number. If you want to put a string, which is basically just words or any characters, like the hashtag would be a string. This would like any characters other than numbers. You would have to put it inside like these double quotes. Okay. So numbers evaluate to numbers. So if you put like variable birthday equals 2 plus 7, this would evaluate to 9. So the computer would store as variable birthday equals 9. And then numbers and strings evaluate to strings. So if you have 4 plus ever, it would evaluate to be all in the double quotes and be forever. So if you have variable birthday is 8 plus May, and then you want to print this. Oops. As you can see here, it combines it into one string, so the whole thing is in the quotes. Okay. And then strings validate to strings, obviously. If you combine two strings together, like cup and cake, it'll combine to cupcake, pop and corn to popcorn. Okay. Variables can only hold one value at a time. So if oh shoot, okay. If you guys have um and then later you change the value to this, it's not going to store both 4 and 6. It's going to store 6. So once you change it, this value, the first value is scrapped, and this is what's kept. Okay. Variable names can't use quotes, can't have spaces, and they have to start with a letter. So you can't do like, oops. Like that wouldn't work. So it says unexpected 6. It has to start with um a letter, and you can't have variable. Well, you can technically, but it's kind of like it'll mess things up. You shouldn't have name different variables the same thing. Just like change it. It'll show an error. So if you guys were looking on my screen, to start a new variable, you put var and then the name of the variable and then whatever value you want to assign it. So you can either just have var and then the name of your variable and then just end it there. That's just you like declaring it, and then later you can assign a value to it, or you can assign a value like up front and just do var cake pop equals 6. Either way is fine. If you guys look at the blocks, and I'll show you this when we're making our like app thing, but you guys can either use text or blocks. Blocks is probably easier for like beginners, but if you guys want to use text, it's fine. You could see here, there's a block with the equal and whatever, or just a block with var by itself. And then this block assigns a value to like an already declared variable. Like these two declare a new variable, while this one with no var just puts a value in an already declared variable. Oops. Like I said, to change a variable, don't use var again because that'll declare a new variable. In JavaScript, you just put the name of the variable equals whatever. You don't put var again. And if you're just starting, it's kind of helpful to imagine an arrow going towards the left to symbolize like that value being put into the name. So on JavaScript, it's just going to show as an equal sign, but you can imagine an arrow going that way. So the 4 is being put into cake. Okay. Next. Do you guys have any questions on that? Okay. Next is Booleans, which and Boolean expressions are expressions that only evaluate to true or false. So there's only 2 options. So think about when we were talking about binary, there's only 2 options, true or false, yes or no. This is what a Boolean is. So yeah. Most of these are logical values, and they use comparison operators and evaluate to the expression given to be either true or false. So what does that mean? These comparison operators are listed here. So you guys probably know this from math, but some of these are different. This is less than, this is greater than. Equal to is different from just one equal sign. Just one equal sign is used for putting values into variables, but for Booleans, we use 2 equal signs next to each other in JavaScript. On the exam, the syntax is all different, but whatever. Okay. less than or equal to is a less than and then equal, greater than or equal to is greater than equal, and then not equal to is an exclamation mark and then an equal sign. So this evaluates to the opposite of whatever is normal. So if you had four equals to four, that would be true, right? But if you had four and then the exclamation mark and then equals four, this would be false. So yeah, it's just the opposite of whatever it normally is. Okay. For Booleans, you could use variables to check if something is true or false. So this makes it easy for like situations or making a decision to check if someone's old enough to ride a roller coaster or check if you have enough money to buy something. So for example, let me delete all this. If you want to check if you're old enough for something, let's say the variable age is 5, you're 5 years old. And then the Boolean would be oh, shoot. Okay. If let's say on the roller coaster you have to be at least 9 to ride. So if age is greater than or equal to 9, ride equals yes. And then we should also declare ride. And look, notice how for age I put a value in, but for ride I didn't. I just declared it because we don't know if it's going to be yes or no. It's depending on this value over here. Why is it? And then let's just print console.log basically just prints it to down here. So let's just print the answer to see. Oops. Oh, oops, I forgot something. Hold on. We'll learn the if else in a second, but it's pretty self-explanatory. If you're older than 9, the ride is yes, and if you're not, ride is no. So let's just do that. Okay, so it's no, because 5 is less than 9. You're not 9 years old yet. Okay. So notice how we use a lot a comparison operator greater than or equal to check the variable age. So yeah, you can use booleans and variables together. Okay, logic flowchart. These might show up on the exam. They're not as common, but whatever. They're basically what's shown over here. So the diamond or a parallelogram is going to be a condition or a question that you have to pass. This can be either true or false. There's only 2 options, remember that. There should only be 2 arrows coming out of a diamond. And then the rectangles are the result of the condition. So if it's true, this happens. If it's false, this happens. And these diamonds can lead to other diamonds. So you can see here, if it's false, another question pops up. So yeah. Okay, so some examples. If you want to check if 6 minus 5 is greater than 7 plus 8, that's false. Obviously, 1 is not greater than a 15. 10 divided by 2 equals 5, that's true. And so on, whatever, you got it. Okay. This is kind of the same thing. Conditionals allow computers to make decisions using Booleans as a criteria, which in other words, the Boolean is the condition. So this is what I was doing over here. So if a certain condition is true, this happens, otherwise or else this happens. And the condition in this if statement, like in the parentheses you can see here, is a Boolean with a comparison thing. Okay, so the types of conditionals are an if statement. So if the condition inside the statement is true, the code beneath the statement will run, and if false, nothing will happen. So this is this, as you can see, if whatever age is equal to 9, whatever, But notice there is no else. So if this isn't true, nothing will happen. If else statement, this is lines 3 through 7 here. You can see here, if the condition inside the statement is true, the code will run. And if it's false, the code beneath the else statement will run. So this time there is something that happens if what is inside here won't happen. That is not true, sorry. Okay, if else statement. Okay. If the condition inside the statement is true, the code will run. If it's false, the second condition is true, the code beneath that statement will run. If both are false, the code beneath the else statement will run. So this is basically adding another one. So if this first condition fails, we're going to put another condition. So if age is greater than or equal to 6, let's say. And then if this isn't true, then whatever's under here will run. So you're just putting an extra condition. Okay. So again, you're using the Booleans as the conditions inside the statements, but you can combine multiple Booleans to make it more complex depending on what your goal of the program is. So you can combine two by using these two and symbols. So this means both values must be true. So age has to be greater than 8, and you have to have more than $20 in this program over here. These two lines, which are on the keyboard, is the one you have to press shift, and then the one with like the /, it's like under the delete button. This means one of the statements must be true for the whole statement to be true. So this is basically saying or. So if you had it over here, it'd be you have to be at least 8, or you have to be older than 8, or you have more than $20. It's either or, not both. Okay. Does anybody have any questions on that? Okay. Now let's do functions. Functions are basically a name grouped of programming instructions. A function calls a command that executes the code in a function. So let me just show you how it would look like on here. Let's say you want to repeat this process that we just did multiple times, but you don't want to write it out and copy and paste it multiple times because that could lead to errors, right? So you want to make a function. So let's just call this function check age because that's what we're doing. And you would put all the code you want to run under here, and then in order to call the function, which is just making it run, because having this just like defines it. This is actually calling it, making it run. You just put check age here. Okay. This, like I said, allows us to repeat lines of code with one command, which reduces repetitiveness and error, and organizes the code and reduces the length of code. And it makes it shorter and not unnecessarily long. But it's important to remember that functions don't make the computer work less, because when you call it, the computer is still referring back to the original lines of code here. It's still going back and doing the whole thing. It's just visually for humans more organized. Okay, so I have an example here. You can see I define the function in lines 4 through 11, and I called the function twice, lines 12 through 13. In this example, it's kind of, you can't really tell how useful a function can be because I'm only calling it twice, but it's just for the purpose of the example. In actual code, you might have to repeat some sections of code like 5-10 times, I don't know, and it can get really messy really fast. So it's really useful to have a function. Okay. An important thing to remember while you're making functions or using functions is that there's such thing as global and local variables. So global variables are used throughout the entire program. This is when you define the variable outside of the function brackets, right? So these first two lines of age and ride would be global variables. And you could use these anywhere in the program because you define them outside of the function. But local variables are only used in one specific section of the program. And this is if you define a variable in a function within the bracket. So if you have this variable, I don't know, dollars, that's how much money you have, right? This you can only use in the function. And then another part of functions, they can have parameters, which you guys might have saw over here. There's these parentheses over here. And this replaces a local variable, and it's used as a placeholder for values that we pass through the function. So if you want to do check age, sorry, let me get rid of this. And you want to use a variable for age in your program, but this is obviously going to change with each time you call the function. You could put age in here as a parameter, and then whenever you call the call the function, you could put in these parentheses a number for age, and that's going to replace your variable here. And then in the function, you might put this here. Okay, I'm going to get rid of all this. And okay. And whatever you put in the parentheses when you call your function, which in this case is 6, replaces age and then replaces all the instances of age in the function. So 6 would go in place of age here, 6 would go in place of age here. Okay. And then argument is just the value past the parameter. So in this case, the argument would be 6, the parameter is age. Again, this allows us to use the same concepts in the same program for different values when you have to do the same thing but with different inputs. And this is a form of abstraction, which is pretty an important topic on the exam, because it's like allowing you to use something general for more specific cases. Okay. So you could see here, using global variables, they're declared at the top of the program, they're not in the function. And then using local variables and parameters, you have the parameters here, age and money. And then when you're calling it, you put those numbers that you want in place of age and money. So 4,75, 24 age, 7 money, whatever. Okay. And then the last thing about functions you have to know is returns. So returns stop the flow of function. So if a return is inside of a conditional and that conditional is met, it's true, the function will end there. And then returns also return a value to the place where the function was called. So if you have this function over here, oh wait, I have an example here, never mind. Let me just zoom in. Right here, you can see there's a return on line 8. So the function will return whether or not you can go. So yes or no. So here, console.log again just means printing it to the console down on the bottom. So it's gonna print the return of this function, which is either yes or no. But if this return were to be inside the if part and this was met, then the function would just stop after the if. You have to remember returns stop the function completely, no matter where it is. So that's why you guys, when you're like actually coding stuff, you might make mistakes and put the return too early, but that's for later. Okay. Okay. Libraries are a collection of functions that can be used in many different programs. So they're basically open source collections of functions that people share so that others can use. Because there's some pieces of code that are like really common. Like let's say you want to find the maximum number in a group of numbers or the minimum number. These other programmers share with other programmers through libraries. So libraries are similar to how you name variables. The name can't have spaces, except but they're different from variables because you have to capitalize the first letter of the name. So an example of a library in here that's built into the thing is math.round. So so you can see here the name of the library is math. And the specific function you're accessing from that library is round. And what that function does, you can see here, it rounds a number to the nearest integer. Oops. And you can see math is capitalized. Okay, library documentation. So when you make a library or you're using somebody else's library, they have documentation for how each function works and the complete list of all the parameters in each function and what they do and what type of variable they are. So are they strings or numbers or whatever? And then what will be returned as a result of the function. So one type of documentation is called application program interface, or API for short. It's shown here. So if you have your two functions in your library, cake cost and average cake, you could see here they tell you what this function does, calculates the cost of making a cake, and then it defines all the different parameters. So the parameters here are tiers, flavor, and return. Tiers and flavor, and then the what the function returns is the cost of making the cake, and this is a number. And then you can see here the variable flavor is a string, and the variable tiers is a number. So all the different types of parameters are documented. Okay. Okay, like I said here, this is the name of the library, dot, and then the function in that library you want to use, and then the parameters you want to input into that function. Okay. The next topic we're going to learn is lists. These are essentially multiple variables stored under one name, and these different variables are separated by commas. So, similarly to variables, when you name a list, you can't start with a number and you can't include spaces, and lists are indicated with square brackets. So let me show you guys here. If you want to name your list numbers, for example, and you have just random numbers, should I spell numbers wrong? Okay. So you just have the name of your list, which here again does not start with a number, and it doesn't have spaces, it's just numbers. And then you have multiple values stored under this one name. Okay. Lists are super helpful because you could run through them easily. So each element is each of these numbers. So 8 is an element, 6 is an element, 11 is an element, and 0 is an element. Each element has its own index, which is where the element is located on the list. So on the exam, which is pseudocode, you start from 1 and you count up. So 8 would be at the index 1, 6 would be at 2, 11 would be at 3, and 0 would be at 4. But in JavaScript, and I know this is kind of confusing, but you'll just have to remember it. On JavaScript, you start from 0 and you count up. So 8 would be at the 0th index, 6 would be at the 1st, 11th would be at the 2nd, and 0 would be at 3rd, sorry. So that's just something you have to remember when you're actually taking the exam. It's going to start at 1 and count up, but at least for this class, it's going to start at 0. Okay. The length is how many elements the list contains. So for pseudocode, this is just going to equal to the last number of the index, right? Because 0 is at the 4th index and there's 4 values in this list. But in JavaScript, it starts from 0, right? So it's always one more than the last index. So 0, it's 0, 1, 2, 3. So 0 is at the 3rd index. But there's 4 values in the list. So it would be 3 plus 1, which is 4. Okay. In order to create a new list, like I showed you here, you have var and then the name and then equals whatever values. And you could put strings in here too. You could put cake, mix, oil, butter. And then to access a value in the list, let's say you want to access cake. You would put on console.log and then the name of your list, so ingredients. And then in the square brackets, you're going to put the index of the thing you want to access. So cake is at the first position, which in JavaScript is the 0th index. So you're going to put 0 here. And that's going to print cake down here if it works. Okay, yeah. So again, the list name and then in the square brackets, the index of the thing you want. Okay, and then to change a value in the list, let's say you want to change cake to cupcake. You're gonna put the index of the thing you want to change. So the list name, which is ingredients, and then square brackets, and then the index of the value you want to change, and then you're gonna put the new value, so cupcake. So now whatever is at index 0, which is cake, is changed to cupcake. And then to remove an item, you put remove item, and then you put the name of the list that you're removing an item from, which is ingredients, right? Comma, and then the index you want to remove. So let's say you want to remove cake. So that's at the first position, which is the 0th index. So you're gonna put ingredients, comma 0. And then that should remove it from the list. So to check if that's true, we're gonna print the list afterwards to see what's still in the list. Oops, ingredients. Sorry, I can't spell. So yeah, you can see now there's only mix, oil, and butter, and cake is removed. So remember now that it's just these 3, all the positions have moved forward. So mix is now at the 0th index, oil is at the first, and butter is at the 2nd. Okay. If you want to add an item to the end of the list, it's called append an item. So you're gonna put the name of your list again, and then the new item. And sorry, in this case, you don't have to put the index because it's append just means add it to the end of the list. So if you want to add, I don't know, sugar to the end of your list, you put the name of your list, ingredients, comma, sugar. And then again, we're just going to print the list after to check that it's working. And yeah, you look down here, sugar's at the end now. Okay. If you want to insert an item at a specific index, not just the end, you're gonna put insert item and then parentheses and then the name of your list, the index you want it at, and then what you want to insert into that index, so the new item. So if you want to put, what else do you put in cookies? Sugar, butter, eggs. Okay. So insert item. In the parentheses, you're going to put the name of the list you want to edit, which is ingredients, right? Comma. And then the index you want it at. Let's say I want it to be right before sugar. So that's going to be 0, 1, 2, the third index, right? Because look, mix is 0, oil is 1, butter is 2, and then next would be 3. So that'll be the third index. And then you put the item you want to put in. So that's going to be eggs. And put a semicolon at the end. And then you could see here, eggs is inserted in the third index before sugar. 0, 1, 2, 3. Okay. Does anybody have any questions so far? Okay, let's continue. Sorry. Loops. So loops, like the name suggests, are just a piece of code that repeats over and over again until a certain condition is met. So there's two main types of loops you have to remember for this class. There's the while statement, which means that the code beneath the statement will continue to run as long as the condition inside the statement is true. So while condition is true, this is going to happen. So let me show you what that looks like. Here, while, let's say, age is greater than 10, or wait, let's say age is less than 10, you can't read the thing. So, well, try equals no. Actually, wait, I don't want to do that. Well, age is less than 10. You're gonna add 1 to age. So let's declare age. So age starts with 0. As long as it's less than 10, you're gonna keep on adding 1, and then once it reaches 10, or it's greater than 10, actually, once it's greater than 10, you're gonna stop adding 1. And I'm just gonna print the last number that age gets to, so we can see what number it ends up as. Okay. So you can see here, it ends up as 10 because 10 is not less than 10. So then it would stop. So you can imagine this would start at 0. 0 is less than 10, so you do add 1 to age, so that'd be 1. So now age is 1. 1 is less than 10, so you add 1 to 1, which is 2. Keep on going. Let's just fast forward to when age is 8. 8 is less than 10, so you add 1 to 8, which is 9. 9 is less than 10, so you add 1 to 9, which is 10, and then age is now 10. 10 is not less than 10, so this does not run, and this loop is done. So you move on to printing the age, which is 10. Okay. Repeat until statement is the opposite of a while statement. So as long as the code beneath this statement is false, it'll run. So here, repeat. You're gonna repeat until a certain condition. And as long as the condition is not true, you're gonna run whatever's under here. Okay. So some shortcuts, I guess, that programmers often use if you want to add 1 to something every time, like I was showing before, I was doing age equals age plus 1. But you could just do age plus plus. That just adds 1 to whatever your variable is every time. And then similarly, you can do that to for subtraction. So age minus minus subtracts 1 from age every time. And this is again just the same thing as age equals age minus 1, but shortened. Okay. And then a for loop combines all these factors. So what you have for, and then in the parentheses you have a variable that is going to be added every time. One is going to be added to the variable every time. And then a condition. So it's going to stop. This loop is going to stop once this condition is met. And every time this loop runs, you're going to add 1 to this variable we just declared. And this is a local variable. Okay. So technically any variable can be used, but I is used most frequently. There's not really any reason. I mean, you can, in your head, you could say like it stands for iteration, but it doesn't really matter. We just need something to stand for that variable. It could be J, it could be K, it doesn't matter. Okay. Okay, traversals use a for loop to traverse or go through a list. So let's say you have this list, favorite pets, and you have a for loop. As long as, and this is what I was saying, where it's easy to use lists to go. It's easy to use lists so that I can go through. Oh, my Siri just went off. All right. Lists are useful because you could go through them in one action. So in this case, I is counting what index you're at in the list. So as long as I is less than the length of list, the program will run, and each time you're going to add 1 to I. So you're going to move on to a new index each time this is running. So you're going to access whatever index the loop is on right now here, and then you're going to add 1 to the index. So it's a new index, it's a new value, and you're going to access a new value each time. Okay, these are iteration, sequencing, and selection. These are the main 3 components that programmers use to create a program. We've been talking about it this whole time, but now we're just like defining it. So iteration is just repetition. Usually when you're asked to identify iteration, it's loops because it's just going over and over again. It's repeating. Sequencing is going in a sequential order to achieve something. So it's going in a specific order. So this is technically used in every program, but it's really going to be shown when the order is super important to the program. So let's say you have certain steps, or you have a sentence that you're printing and each step is a word or something. You can't really mess the order up of words or it's going to sound weird. Or like directions for a robot, left, right, forward. Those have to go in a specific order so that the robot is going in a specific direction, in a specific path. And then selection is instructions determined by a certain condition. So these are usually shown through if statements. Obviously these, like if statements, you have to pass through a certain condition to run the program. So you're selecting specific variables that pass through that allow you to run the program. Okay, so these are just a visual. This is just a visual of all 3. Iteration, if something is true, you're going to repeat it over and over again until it's false, and then you stop. Selection, If it's true, you do this. If it's false, you do this. Sequencing is going in order. Okay, let's do. Okay, I don't know if we have time for practice. Let's just move on. Okay. Okay, algorithms basically just solve a problem. A problem is a task that can or cannot be solved with an algorithm. Not all problems can be solved with an algorithm. Because in order for an algorithm to truly solve an issue, it means that it could solve all possible inputs. And for some problems, algorithms can only solve some inputs and not others, which means that it technically has not fully solved it. And then the algorithm is just a finite set of instructions that accomplish a task or solve a problem. And keep in mind there are multiple ways and multiple algorithms to solve the same problem. And they can be expressed through natural language, pseudocode, diagrams, or programs, obviously. And again, they're created using these three components: sequencing, selection, and iteration. Okay. I don't know why this is here. Okay. And then to measure the efficiency of an algorithm, it's just a measure of how many steps are needed to complete it. Obviously, the less steps there are, the more efficient it is. And then I'm just gonna show you guys some different speeds of algorithms and define which ones are considered reasonable time and which ones are considered unreasonable time. Okay, so the first one is your basic linear search. So if you think about it as in like you're searching for a certain number and a list of numbers, you're gonna check every number to see if it matches up with the number you're looking for. So you're checking every element in a list in order until you find the desired value. So obviously, since you have to check every value, it's gonna take kind of long depending on how many values you have, but it's gonna require the same amount of checks as the number of values you have in that list because you're checking every value in the list. I mean, if you're lucky, the value you might be looking might be earlier on in the list, but in order to look at the true efficiency, you have to look at how long it takes worst case scenario. So let's say your number that you want to look for is at the end of the list, then you would have to check every value on the list, right? Okay. And then the next type is binary search. So this basically starts in the middle. Let me draw this. So it's easier to explain that way. Okay, so let's say you have a list of numbers, 1, 2, 3, 4, 5, and it's important to note binary search only works on sorted lists, so they have to be in sequential order. It can't be like 2, 4, 7, 5. It has to be 1, 2, 3, 4. It starts at the middle, so it would be 3, right? And it checks, is 3 the number you're looking for? Let's say 5 is the number we're looking for. Is 3 the number you're looking for? No. It's gonna see, is 3 greater than or greater than or less than the number you're looking for? 3 is less than. So now it knows, since it's all in order, everything to the left of 3 is gonna be too little, because 3 is already too little and it's in order. So it's gonna delete this whole half. Okay, then it repeats this process again over here. When there's only an even number of numbers, it just picks random ones, doesn't really matter. But for the sake of looking at the worst case scenario, let's say it picks number 4. 4 is less than 5, so we know it's not this one. And then last number remaining is 5, and you found your number. This is obviously faster than just looking through every single number. And this is gonna run in logarithmic time. So you can see here, this is how fast. I mean, this is how fast the number of checks you have to do grows compared to linear, which is all the way up here, while this is down here. Okay. The next type of speed is polynomial time. Basically any algorithm whose efficiency is n to the power of a number is going to be polynomial time, and you can see here it's still kind of bad, like it still grows super fast, especially compared to binary search, but it can get worse, and you'll see here when the variable is the exponent, so 2 to the power of n, 3 to the power of n, it's exponential, so it grows super fast. You can see here. And lastly, we have factorial, and you guys might know this from math or you might not. If you have a number with an exclamation mark, that means factorial. So you basically multiply all the numbers from that number to 1. So if it's 3, you multiply 1 times 2 times 3. If it's 4 with exclamation mark, it's 1 times 2 times 3 times 4. So yeah, you can see it also goes super, super fast. This is what it looks like all on a graph, except for factorial or whatever. You could see here exponential grows way too fast, so it's unreasonable. There's too many checks. Polynomial is reasonable. It's still bad, but it's reasonable. And linear and logarithmic are also considered reasonable. Okay. And this whole time I've been saying reasonable and reasonable time. Reasonable time are just algorithms with polynomial efficiency or lower. And then unreasonable time are algorithms with exponential or factorial efficiencies. Okay. I'm gonna move this down here. Okay. Another famous problem that algorithms have not been able to solve perfectly is the traveling salesman problem, which is basically asking what's the best path. So think about like a mailman who's like has multiple stops, and they have to find the best route, the fastest route, in order to stop at all these houses and save the most amount of time and the most amount of gas. As you can imagine, if you have like hundreds or like thousands of houses, it's not possible to solve in reasonable time to check every single option to see which one's faster. It takes a lot of computing power, especially as there's more stops, so it doesn't run in reasonable time. So instead, a heuristic is used. A heuristic is it's a good enough or close enough solution to a problem when an actual solution is impractical or not possible. So they're used for problems that algorithms can't solve, or problems that algorithms can solve, but in a super unreasonable amount of time. So these are the two types of problems. Decision problems. Is there a path? That's usually reasonable time. It just checks if something is there. So checks if a number is there, checks if a path is there. But the types of problems that don't run in reasonable time are optimization problems. So what's the shortest path? Or like anything like that, yeah. Okay. And then this is what I wanted to show you before. Under the problems umbrella, there's decidable problems that can be solved and undecidable problems, which means they can't be solved. If they're undecidable, you use a heuristic, and then also if it's unreasonable, and the reasonable time, you just use an algorithm. Okay. Now I'm just gonna go over the pseudocode. Oopsies. Okay. So, instead of having var to put a value in a variable, in pseudocode on the exam, you're just gonna have an arrow, which is kind of easier visually to see a value going into a variable name. Okay. And then if you want to display something or print something on the screen, it's not going to be console.log like I've been using here in line 5. It's going to be display and then whatever expression, which is, again, I guess easier since it's literally telling you display. Okay. Input is just input from the user, depending on the program. These are pretty self-explanatory. Plus, is just adding 2 items. Minus is subtracting 2 items. This asterisk is multiplying, and then this backwards slash is division. Okay. This we haven't talked about. A mod B. Mod, it just means the remainder when it's divided by something. So if you had 17 mod 5, 17 divided by 5 would be 3 remainder 2. And so it's just going to display the remainder, which is 2. So this is just the remainder when two values are divided. Okay, and then random A and B is just finding returns a random number between A and B and includes A and B. So if it's random 3, 7, it's going to choose a random number between 3 and 7, and it can choose 3 and 7 included. These are self-explanatory. The operators we're talking about, but in pseudocode, there's not going to be 2 equal signs, it's just 1 equal sign. The not with exclamation mark is just going to have a dash through the equal sign. Greater than equal to, these 4 you all know. Okay. If something is not true, it's going to have not. Instead of the 2 and symbols, it's just going to say and. Instead of the 2 lines, it's going to say or. This is self-explanatory. If something, I'm going to skip through the self-explanatory ones. Okay, this one, you repeat a certain number of times. It might say 3, might say 4, and then this is just the statement below is just going to repeat that number of times. This is the repeat until I was showing you before. Okay, this is a list. These values are separated by commas, just like I showed you here. It's not up there anymore, but whatever. If you want to change your list completely and put a new list in the list of the same name, you put B list and then an arrow going into A list. If you want to access an item in your list, it's the same thing, where it's the list and then your square brackets and then the index of your list. But remember, in pseudocode, the indexes start at 1, so it's not at 0. Okay. If you want to put a element of a list into a variable, it's gonna be like that. If you want to put a variable into the index of a list, it's like there. Okay, this, if the length of your list, if you have like 3 items in your list, the length will be 3, right? So if you want to use that in your program, you just put length and then the name of the list you're accessing in the parentheses. And then this one, for each item in list, it's basically doing this block of statements for every item, every element in your list. These are procedure is just like function. And these are the parameters. This is the return. Okay, this is like, so there's gonna be like a grid and there's gonna be like a little robot on there. It's just gonna be like a dot or an arrow, but it's gonna you can give it commands. So move forward, rotate left does not mean move left, it just means turn that way. So it's not moving any blocks, it's just turning. Rotate right is just turning, and then a can move direction is just checking if it is able to move in a certain direction. So can move forward means there's a space in front of it that it can move to. Okay.